Hello Pre-Calc, these are the notes for section 1.5, which is writing equations that are parallel or perpendicular. So here we go. We're going to start with just a couple of the terms that we're going to be using quite a bit of in this lesson. First one is parallel lines. I think most people kind of have an idea in their head of what parallel lines look like. They are two lines that never touch. So they have the same slope. They're going in the same direction as one another. So they are lines with equal slopes and no point in common. Okay. If you want to think of that another way, think of it as they are the same slope but different y-intercepts. So if you were looking at them on a graph, there's your axes. You would have maybe one y-intercept up here, and then you would have the exact same slope but going through a different y-intercept somewhere else on your graph. Okay? Second term, coinciding lines. Coinciding lines are lines with equal slopes, so just like parallel lines, same slope, but they have a point in common. And actually they have a lot more than one point in common. They have infinitely many points in common. They are actually the exact same line, meaning they have the exact same equation. Okay, so if you were on a graph, once again, you would have one line. I'm going to make this one have a negative slope this time. So there's your first line. Your second line would be exactly the same, right on top of your first one. So they would share every single point along that line because they are the exact same line. Okay? And then our third term is perpendicular lines. Perpendicular lines have slopes that are both opposite and reciprocal. Okay, I'll talk about what that means in just a second. But a horizontal line and a vertical line are always perpendicular. So when you think of perpendicular lines, that's probably kind of what you always picture in your head. Vertical line, horizontal line, they come together and they form a right angle. Okay? When you're talking about slopes and you're talking about this opposite reciprocal thing, okay? Opposite means change the sign. So if your first one is positive, your other one would have to be negative, okay? Reciprocal means if you have a fraction, say 2/3 as a slope, the reciprocal of that would be 3/2. So you basically flip-flop your numerator and denominator. If you had something like the number 4, a slope of 4, and you wanted the opposite reciprocal slope, okay, the first thing you would have to do is think about 4 as a fraction. What would 4 be like as a fraction? It would actually be 4/1, okay? So opposite reciprocal, if you were looking for a slope that's perpendicular to 4, it would become negative 1/4. Okay, so change the sign from positive to negative, and then flip-flop your numerator and denominator. Okay. Next thing we're going to do here is we're going to go through a couple examples. So determine whether the graphs of each pair of equations is parallel, perpendicular, coinciding, or neither. So basically we're going to go through the three terms we just talked about, and if we can't match with any of those, then we will settle on neither, and that is always a possibility. Okay. So first example, we have two equations. They're both in slope-intercept form. Y equals 3x plus 7, and y equals negative 3x plus 7. Okay. So what we want to do is just kind of start by looking at the slopes. So in our first equation, the slope is obviously the number that comes right before the x. So in this case, your slope is 3. And in your second equation, we're going to look at this part here, our slope is negative 3. And then we can just kind of go through our checklist. So if these lines are going to be parallel, they would have to have the exact same slope. That doesn't happen. One of them is 3, one of them is negative 3. They're not the same. Okay. If they're going to be coinciding lines, they would have to be the exact same equation. We definitely don't have that. Okay? If they're going to be perpendicular, our slopes would have to be opposite and reciprocal. Okay? In this case, only one of those happens. We have opposites, one is 3 and one is -3, but we don't have the reciprocal thing going on. If it was going to be reciprocal, our -3 would be -1/3, not -3. Okay? So we went through the 3 possibilities: parallel, nope; perpendicular, nope; coinciding, nope. So in this case, these 2 equations are neither one of those things, or none of those things, I guess. Okay, second example. Y equals -2x minus 12, and y equals 1/2 x plus 3. Okay, so big thing again is to look at your slopes. So in our first one, our slope is -2, and in our second one, our slope is 1/2. Okay, so go through the checklist. They are definitely not the same. -2 is not the same as 1/2. So it cannot be parallel. It cannot be coinciding. So the next thing we check is, are they opposite reciprocals? In this case, yes, they are. We have one negative, one positive. Great. And then we have reciprocal, because -2 is really the same as -2/1. So if you were to flip-flop those, you would end up with 1/2. So these 2 lines, we don't have to worry about the y-intercepts at all. These 2 lines are perpendicular. All right. Next one. We have 2 equations, but this time we are not in slope-intercept form. So I always like to just get them into slope-intercept form, or your y equals mx plus b form. That makes it much easier to make the decision. Kind of hard to figure out what the slope is just looking at it the way it is. So what I'm going to do is I am going to just work on manipulating this first equation, basically solving for y, getting y by itself. Okay? So first thing I would do is subtract 2x from both sides, and I will end up with 4y equals -2x plus 4. Divide everything by 4, and we are left with y equals -2/4, that's the same as -1/2 x plus 1. So there's our slope-intercept form for the first equation. And then our second equation, we can do something similar. Subtract x from both sides. So 2y equals -x plus 5. Divide everything by 2. Maybe we want to throw 1 in front of our x. And we end up with y equals -1/2 x plus 5/2. We can just leave that the way that it is. All right. So now that we can easily see our slopes, we can identify our slopes. Our first equation has a slope of -1/2. Our second equation also has a slope of -1/2. So right now I know for sure they're parallel. Next thing we need to do is just check the y-intercept. So in our first equation, the y-intercept is 1. Second equation, the y-intercept is at 5/2 or 2.5. So since they're not the same y-intercept, they're not the exact same lines, they're not coinciding, but they are still parallel. And then the last example here, we have another 2 equations that are not in slope-intercept form yet. So we are going to want to manipulate those. There's our first one, second one, I'm going to reduce that fraction and also the Two negatives are going to cancel, so 5/3 x minus 4. And there we go. Once we get our two equations into the same form, into slope-intercept form, have everything reduced, you can see that they are exactly the same equation. Therefore, they are coinciding.